Well, hello, everybody. Good morning, good afternoon, good evening, good night to wherever anyone may be across our lovely serverless world. Thanks for joining us here live today for the one and only serverless office hours. Welcome to you if you're joining us via Twitch, and also welcome if you're joining us via YouTube. I'm Julian. I'm a developer advocate, does some serverless stuff at AWS. And today is going to be super cool because we've got new Lambda stuff. And it's not just new stuff within Lambda. This is like a whole new Lambda. So we've got a cast of the good and the greats in no particular order. I won't say who's good and who's great. You'll all just be great. I'll be the good one then. Joining us here today, first up, someone who I think has been on Serverless Office Hours before, Eric Johnson. Welcome back.
Hello. Thank you for having me.
For people who don't know Eric, who's Eric?
Yep.
So we've got Eric, who's one of our co-hosts and does an awesome job. And then the person, one of the people, but the main sort of driver behind what we're going to talk about today, Lambda MicroVMs, is Ayush Kulkarni, who's the product manager for Lambda and has probably sweated blood and tears so much that he had flu yesterday from the drama of getting this across the line, because behind the scenes there's a lot of work that goes into building products and features, and this is a whole new product in a way. So Ayush, welcome back to Serverless Office Hours. For people who don't know you, tell us your journey and how you landed up releasing a cool thing a week ago.
Yeah, appreciate you having us here, Julian. We're really excited to talk to everyone about microVMs today. So, just foreshadowing a bit of what'll come later on, we've been hearing from customers for a while about increasing classes of workloads where they wanted to use the underlying compute environments that power Lambda functions and use them in more flexible ways to run code generated by their customers on the fly, right? And this generated code can take many forms. The latest of it is AI agents, but you also have data analytics use cases, game servers, and a bunch of others. So, we started hearing about this. There were internal flavors of these products, and a bunch of great engineering had already gone into this, and we kind of connected the dots and brought this out.
Cool. Excellent. Oh, we're going to get all into that in great detail. Just before I introduce Ricardo, in fact, Ricardo, you introduce yourself first, and then I'll do my plug.
Well, so hello everyone. I'm Ricardo Marques. I'm a senior specialist solutions architect from Latam, based in Brazil, and I'm happy to be here with those great guys here.
Well, so because Ricardo was awesome and introduced himself from LATAM and from Brazil, we've got lots of people in the chat as well who are joining us. Please let us know where you're from. I will pick the last one who's joined as well, because we've got someone from Sao Paulo already. Ronaldo, Letesta, Silva, 2789. Welcome. Thanks for joining us. Because the serverless crew is coming to LATAM, Eric Johnson is putting together, with the help of Ricardo and some hangers-on like me, we're coming to Brazil, we are coming to Argentina, we're coming to Colombia, we're coming to Mexico. It is going to be a full-on serverless roadshow. Two sort of parts to it. We have some absolutely cool events that we're doing for existing customers. But if you're not a customer or you are a student, you're wondering what the heck all of AWS is about, we've got stuff for you as well. So it's all week. We're doing things with customers. Please reach out to Marco and Ricardo and other kind of people. Please join us. We're going to have one-on-one customer sessions. We're going to have workshops. We're going to have other stuffs. It's going to be awesome, and a huge amount of work is going into it as well. And yeah, across 4 countries, across 3 weeks. And then, on the weekends, we are then going mad on serverless. We're going to do agentic. We're going to do what's new in serverless. We're going to do workshops. We're going to do hackathons. That's going to be Friday night and Saturday. It's going to be absolutely full on. Yeah.
Sao Paulo.
Yep.
Buenos Aires. Bogota. And then Mexico City. Ricardo, I know I destroyed those on how to say them right, but you can probably say them better with the accent. But you people, you all get where we're coming. Yeah. Buenos Aires. How was that?
You did very well.
Thank you. And you're being nice. I appreciate that.
I love the serverless, but I'm just looking forward to a nice steak in Argentina. It's been 20 years since I've been, and meet in Sao Paulo as well. Anyway, we're coming. Please, I'll find some links we can show you so you can join as well. But that's a whole lot coming on. We are live as well. So quickly, just to say hello to everybody. Eerie Edits first up. Welcome back via Twitch as well. We've got Edgar Nielsen. Hi everybody. Hi to you as well. Some guy called EDJ about this as well. Hello from Excellent. So we've got US represented further north in the US. D-Talks from Virginia. Our absolute guru and friend, Sally Geller from Germany. We've got Ishit who's joining us as well. We've got, I think we did Nelson, but they're all Brazil. Oh, we've got lots of Brazilian people. Canada as well. We've got Cold Lake Alberta.
Brazil had a good day yesterday, so they're representing.
Exactly.
Yeah.
D-Talks Tech. Who else? Charisma Points. Absolutely. That's why we're bringing Eric along. And then local to me, Mahesh Devendran. Sorry if I've messed up your name. I'm trying to read very quickly. Hi from the UK. And Jeff Barr, 1960. One and only Jeff Barr. That is quite a tour. Have a great time. We certainly will. Oh, we've got more people coming from Brazil. Daryl Ruggles, who's been on Serverless Office Hours before, from Canada, and more from Canada. So seems to be we've got Canada and Brazil mostly represented with a smattering of other people. Okay, I suppose we have to get back to MicroVMs. So the exciting is out. Yeah, we are already getting onto lots of chat about the World Cup as well. Sally, dangerous talk over there. We won't tell people that.
Here we go. Germany. All right, this is going south really fast.
So we'll bring it up back north. Ayush, you did a bit of an intro on MicroVMs. Let's sort of dive a bit deeper into why on earth we want to build this. What it's for. Why is it different from Lambda, but uses bits of Lambda? Do you want me to share your slides, or what should we do?
Yeah, I'll just go through a few slides here, and then maybe 2 or 3, and then keep it conversational after that.
Absolutely. And remember, we are live, so send us your questions and comments. We would love to talk about it. And if you're watching the recording afterwards, well, you missed us live, but at least you get to see all the good stuff, and you can contact us afterwards as well. There we go. Ish, brilliant.
Awesome. So really, there's I'll let folks read the slide, but essentially it's a new Lambda MicroVMs are a new compute primitive within Lambda, right? Each MicroVM is its own Firecracker virtual machine. It has its own kernel, it has its own memory, it has its own network. It's purpose built for workloads that need to run code that developers building those workloads didn't write themselves, right? These workloads execute code that's supplied on the fly. So there's three key properties that define MicroVM, or 3 key properties that MicroVMs combine in one single compute primitive. The first of these is VM level isolation. Now, when you're running code that's generated on the fly, you don't want to share the OS with other code execution processes or jobs or user sessions, right? Each of these sessions needs its own isolated compute environment. Second, because you're typically building these either interactive applications or fanning out concurrently across many code execution sessions, you want very rapid startup. And if folks have used Lambda SnapStart with functions in the past, they'll be familiar with snapshot-based startup. That's another key property of Firecracker that we've exposed as a key feature in Lambda MicroVMs. And finally, MicroVMs give you the ability to statefully suspend and resume these environments. Now, this is important because each user or session kind of has their long-running state either retained in memory or disk, right? Imagine a data analyst spinning up a Jupyter notebook. They've done a bunch of analysis for several hours. Now they step away. They come back after a period of time, and they want all of that state to be loaded into memory, all the file sets loaded on disk, and they want to do it very easily, right? They don't want to manage state, writing it out, loading it back in, and so on. And so MicroVMs makes all of this possible through APIs directly.
Ayush, can I just quickly go back to that?
Yeah, for sure.
Why not a container? We're talking about VM level isolation. This seems to be a bit of a hodgepodge of containers. Why wouldn't I just use that for my ephemeral workloads?
That's an excellent question. And it comes down to if I'm running 2 different containers within the same VM, they're essentially sharing the same OS under the hood, right? They're sharing the OS of the virtual machine, and so it comes down to isolation, which is what MicroVMs give you.
So this is 100% hardware virtualization, like literally a virtual machine. Think of it as a mini EC2 instance running in the cloud. A lot of people have done a lot of pen testing, and you can't break out of this VM level isolation because we've got things like Nitro under the scenes. We've got all these kind of things to make this. So yeah, if you are a SaaS provider and you are running your absolutely unbelievable secret code from 2 different competing companies, you can be 100% confident that these aren't going to find some jailed exploit that they're going to jump out of a container to be able to talk to each other. Is that the nuts of it, Ayush?
Yeah, exactly.
Cool.
And
Excellent.
if you think of Lambda functions, that's what we've been doing at scale for years. We're the SaaS provider in that world, running functions that are created by millions of users. And so, each function needs its own isolated compute environment in which to run. And that's the motivation for why Firecracker was originally created.
Cool. Yeah, RL55 says containers are not a security boundary. Excellent. Thanks for making our point. Thanks for joining us via YouTube.
Awesome. I'll quickly cover the features and the key specifications at a glance as well. So, with MicroVMs, you can start small, have up to from 0.5 GB and go all the way up to 32 GB of memory. Similar with CPUs, 0.25 to 16 vCPUs. You configure your environment size by providing the memory value, and CPUs allocated in a 2-to-1 ratio, 2 being memory and 1 being CPU. There's a 4x vertical scaling feature that is really cool, right? So the amount that you provision with your MicroVM is the baseline, right? And the motivation behind this is that most workloads usually hover in around their average utilization. It's only during peak short periods of activity that they really spike up, right? Imagine like a JVM process loading up. When the process starts up, that's when it's going to pull a bunch of stuff into memory. It's going to do some heavy computation. And then, while it's waiting for requests, it'll kind of come down to an average or a baseline level of utilization. So that's the motivation behind how Lambda MicroVMs exposes this, where you give us the baseline config. While the VM is on, you're paying for the resources that are, you're paying for the resources at the baseline level, but you also have the flexibility to burst up or vertically scale up to 4x of the baseline. And anything you use above the baseline is only billed when you actually consume it, right? We'll come back to that point. And if there's questions about that, happy to discuss further. With MicroVMs, you also get up to 32 GB of disk. Disk size is proportional to the memory you configure, right? So the way to get larger disk allocation is by provisioning a larger VM. Currently, we support the ARM64 Graviton architecture. We run an AL 2023 operating system environment. And as we were talking about earlier, the compute environments are Firecracker VMs. Today, the maximum lifecycle of a MicroVM is 8 hours. This includes the suspend resume duration, right? And part of this is these are very much ephemeral compute environments. The duration of 8 hours lets people tie it to a workday. And a cool feature is the ability to auto resume environments. Auto suspension is also part of this, where basically you can configure lifecycle policies. And if the VM receives no traffic for a period of time, we'll automatically suspend it with the memory and disk state retained intact. And then when traffic arrives back at the VM, we'll automatically resume it from the snapshot, and you can continue execution where you left off. Billing is per second, and the connectivity model is actually quite different from functions as well, right? With functions, you're used to an invoke handler-based approach. With MicroVMs, you're really running whatever workloads you want within the compute environment. So the way we've enabled connectivity is by giving you an HTTPS endpoint that maps one-to-one with the compute environment. Remember, the primary use case for this is coupling or associating a compute environment to a given user or job. And so that HTTPS endpoint is a unique ingress point for your MicroVM or for each MicroVM. And it supports connectivity over HTTP2, over gRPC, over WebSockets, and you can restrict port access using JW auth tokens. Similar to functions, you can, by default, connect outbound traffic to the internet, and you can also connect MicroVMs to your VPCs. Any questions or any areas that folks would like me to go into more detail here?
We haven't got questions from the chat yet. I think people are talking about football, and it was a busy start to the stream. So one thing I wanted to talk about that was the connectivity. As you said, people need to think of this as one-to-one connectivity. It's not like you send traffic to a Lambda function and it spawns out, thousands, tens of thousands of Lambda functions behind it. You would have a single connection from a single developer, a single agent, a single build job, a single whatever that'll do something in a micro VM as if you would connect to a container or as if you would connect to an EC2 instance, and then that would auto suspend when it's finished, or you can shut it down manually and do all that kind of thing. That's the mental model, that it's this isn't like scale out Lambda. This is one-to-one. You've got a virtual machine sandbox spun up in the cloud very quickly.
Exactly.
Hey, Julian, we did have a question pop up. Sorry. The question is, you pulled it up right now. Any K8s integrations? I'd be curious of what they're asking on what kind of integration. But Ayush, is there any thoughts on that?
Yeah, I just wanted to. I kind of had the same question as you, Eric. Actually, do they mean calling out to micro VMs using like a control plane?
I think either way. Yeah.
Gates, or
I think either way.
Do you mind if I jump in on this? I would say integration, I don't know if you're going to control it through K8 right now. I know there's been some work around, the control plane with Lambda, but specifically Kubernetes, there are some type, and we'll get into type of workloads and examples, but there are some workloads that you want to proxy, right? So you have a control plane that launches the VMs as needed. I'll show one in a little bit where I use Lambda, but you might need something that does something a little differently. And this kind of Kubernetes integration might make a lot of sense where Kubernetes is your control plane, or I've done mine on ECS Fargate because I cannot spell K8s, but that kind of front end proxy is a good example of a workload for that.
Yeah, and just to mention, Scott Scoble 2500, thanks for joining us via YouTube. Running a Kubernetes job on a Lambda micro VM would be quite nice. Absolutely, and it has been done. We have the community has gone wild with this. We've been trying to catch up with what everybody's doing, and running Kubernetes job on a Lambda micro VM would be quite nice. Is quite nice. And then Argon goes on to say, sounds very similar to Bedrock Agent Core runtime.
There's a reason for that.
Ayush, do you want to explain that?
Yeah. So I mean, as I was saying earlier, this tech internally powers a lot of services, and one of them is Agent Core runtime. Now you can think of micro VMs as being the compute primitive, because of which we expose APIs that are more akin to launch a VM, connect to a VM, or sorry, not connect to a VM. That's the HTTPS endpoint that we were talking about earlier. That's what you would use to connect to the VM. However, you're using your favorite connectivity protocols. But yes, that's that. To briefly answer your question, this is the compute primitive that powers many services that need ephemeral compute with strong isolation, rapid startup speeds, and the ability to suspend resume.
So if you think of Lambda functions as a service, Lambda micro VMs are in a way Firecracker as a service. And then in a way, Agent Core Runtime is a user of Firecracker as a service. And there are other AWS services. Aurora DC Call, interestingly, uses Firecracker under the hood. It doesn't quite use micro VMs in the same way, but you can imagine, batch workloads and other kind of things as a great isolated, customer runtime. This would be a great kind of thing. And somebody said just back, tenant isolation not possible with micro VMs. Yes, no, but yes. No, because we don't have multiple tenants within a micro VM unless you build it yourself. Sure. But the tenant isolation is there because you just have another micro VM. So in a way, every tenant would have their own micro VM. If you think of it from Lambda functions, and this is probably a poor analogy, but when we have Lambda functions for tenant isolation, we spin up different execution environments for those tenants. You would do the same kind of thing. You just need to manually handle that and set up a separate micro VM for your tenants. We did have a question again about the compromise here for this micro, and from isolation point of view, it is still prone to VM escape. I would say technically yes, but VM escape is pretty much impossible with our Firecracker and our Nitro solution. We've had this pen tested. We have government agencies, we have banks, we have everything using Lambda because of its secure isolation, and this uses that as well. So I I would not use this because you're worried from a VM escape point of view. Even if you did manage to escape the VM, there are so many layers of the onion to get out. And ultimately, you've got a network port and you have a keyboard port. And that's it. I think that's the only thing you can even get out of these Firecracker MicroVMs. There's a whole, have a read up on Firecracker and you can see all the stuff that is done there as well. Yeah, awesome, awesome questions as well. Ayush, carry on. We've got demos to show as well. So I love the engagement. Thank you.
I think, just to sort of summarize the delta between how customers are used to interacting with functions versus how they'll now interact with microVMs, we have the summary slide over here, right? And the idea with functions, again, is they're event-based, either direct sync requests, async requests, or connecting with the various event source integrations that we support out of the box. Each function execution today runs up to 15 minutes. Function executions are inherently stateless, right? When you go back, there's no sort of guarantee that when a request comes back to the same compute environment, any state that was previously computed and stored either in memory or on disk will remain, right? And that's a function of the function form factor, right? And as Julian was saying earlier, by their very nature, functions are auto-scaling, right? You call a function endpoint, we spin up multiple execution environments behind the scenes to handle an increase in incoming requests. And of course, you're all familiar with the handler model, right? All of that changes with microVMs because they're designed fundamentally to solve the use case where you need to vend a separate compute environment to each end user or job because they need to run their code in isolation, right? So each microVM supports persistent sessions of up to 8 hours. You can statefully suspend and resume execution either with the idle lifecycle policies that we briefly touched upon earlier, or by calling the APIs directly. The lifecycle can be either developer controlled or lifecycle controlled in those two ways. And the connectivity model is any app on any ports that you want, right? So once you have that ingress HTTPS endpoint, you can open up specific ports, scope your authentication token to make sure that any other ports are not reachable, and run any app over layer 7 protocols that you can then connect to from the outside.
Hey, Ish, there was a question on here that you might want to, if you can kind of talk through, and I'm having a problem grabbing it. Here we go. Does the suspend count towards the 8-hour session time?
Yes, it does.
Okay.
Yeah, so you can think of 8 hours as the maximum lifespan of the compute environment.
Got it.
Yeah,
got it.
Of the microVM. Yep. Cool. I know we have some demos as well, so maybe we can actually segue into that now.
Yeah,
you guys
I'll do a quick demo, literally just a few minutes just to show that up, and then we'll get to the Eric and Ricardo have awesome demos as well. But yeah, Scott Scoble did come back. Can the suspend state be forked so that multiple microVMs can run from a single microVM genesis?
That is a very interesting ask and one we've heard a lot. It's something we're considering, but it's not currently supported.
Yeah. However, well, in fact, I will explain how you can do the same kind of thing. When I'll show it quickly. Let me find my screen. There's a lot going on today. I need to remove.
Screen's right in front of you, buddy.
Yeah, too many. Okay. I have basically the way that microVMs work is you give it a Docker file and it goes and builds a Docker container. You create a Docker container in ECR, and then microVMs builds a microVM from that Docker container. And so what I'm going to do is I'm going to show you running VS Code as a server, because obviously we want to bring servers back into serverless. And so we're going to run a sort of persistent up to 8 hour long Visual Studio
I cannot believe
server.
you just said that. I'm going to tackle you somewhere from the side.
I'm safe.
You are.
So basically, the Docker file would look like this. I'm literally bringing the code server. I'm going to use root. I'm going to install a whole bunch of stuff. And I'm going to copy some application files. And this is just a Docker file. And I'm going to run the script to start. And all the start script does, looks at some lifecycle hooks. We'll cover that as well. And it's basically going to execute code server. So this is pretty simple. This is going to be a stateless server. I've actually, because it takes a bit of time, and it's basically a Docker image, and push that Docker image up, and then a MicroVM is going to create that from that image. We talked about the auth, and we'll cover that, but basically I'm just going to create a token from the authentication, and this token is available for expiration in minutes. So I've just done an hour-long token, and then what I can do here is basically, in order to connect to this, there's an HTTP endpoint. I'm going to run a little proxy locally to be able to do WebSocket reverse proxy for the Lambda MicroVM. So I'm going to connect locally. It's going to do a WebSocket thing and connect that remotely to the MicroVM. So I'm now just running that local host. It's going to point up. I have then previously cloned the serverless patterns repo. So you can see I'm now reconnecting to this MicroVM. It is hopefully going to come up with a lovely kind of browser. Of course, we do live demos and things are slow. Disconnect, trying to reconnect. We will restart. Oh, well, an absolutely blank screen. So you can see that nothing is happening. Let's just go back to my Kiro and say, it is all there. So maybe I've just got a browser issue, but it's definitely authenticated. The MicroVM is up and running. It's tested the connection to the VM endpoint. Well, that was a good demo, wasn't it? That's why we do this.
We'll come back around. This is how lives work. Yeah. Let's go to Ricardo's, and then we'll come back to yours.
Yeah, we'll go. I mean, but basically, even if we don't come back around, so basically, this is just going to bring up a Visual Studio Code. I'm browsing it to it locally via WebSockets. It then comes back up to my thing, and I could have run some code. I could have even done some AI checking and things in that as well. So we'll maybe come back to that. You'll sort of have to believe me. Ricardo, over to you. Maybe you've got a working demo. We'll see how we go here today.
Let me share my screen here.
Is that the one with the code review?
Yeah.
Excellent. So yeah, just tell us the use case for this, and then we can have a look at it.
Yes. So this sample is for those customers that want to run CI/CD pipelines using AI agents to do code reviews, code build, code test, and etc. So in this sample, let me show the diagram here. We have a MicroVM with an app developed in Python running along with a Kiro headless mode. So what this application does is receives a HTTP request with data from a pull request, retrieves the Kiro API key from a secrets manager, pulls the code from a repository. I used code commit here just for simplicity, and start executing Kiro in headless mode to do the review and then send back the revision. As Julian said, we need to create the image, and after the image created, you can spin up the MicroVMs. I will jump straight to the MicroVM part, just to sake of our time. Just switch to my terminal. So before going to the terminal, let's go to the sample readme. In this readme, we can see the instructions to run this code Kiro reviewer. So we need to execute a deployment script to start everything and create the image. And when the image is ready, you can start calling the run MicroVM. This command starts the MicroVMs. So let me start my MicroVM here. Actually, let me copy everything. It should be faster. So what I'm done here is, first, I'm creating a new MicroVM. Second, I'm generating the auth token. And finally, I'm making an HTTP request to Kiro reviewer. All right, so yes, the MicroVM was created. You can see the ID here. The endpoint, it's an important point. Each MicroVM has its own endpoint, so you need the endpoint to call your MicroVM. And finally, the request was done. So we can follow the request, look into the CloudWatch logs. For example, here we have here my CloudWatch logs, logging everything that is done inside the microVM. We can see here. Let me. You can see here, for example, when Kiro fetched the secrets manager to get the Kiro API key, start cloning the daemon, etc. Let me get resume here. While Kiro is reviewing our code, let me go to the CloudFormation template just to see what we are spinning up with the template. So our CloudFormation template has few resources: a log group, as I said, as you saw, a microVM build role, which is the role used during the image building phase, the microVM execution role, which is the role used in this time when I execute a microVM, the code commit repo with the code with the facts that Kiro is reviewing right now, and the image, microVM image itself. So we need to provide some parameters, but among them, the more important are the base image, which is the image provided by the Lambda service to run your image over it. The S3 bucket, where you store your Docker file and application files. And for this use case, we are also creating a local environment variable with the ARN of the secret manager, where we have our API key storage. And only this. So let's go back to the execution. I believe it's finished. Yeah. So you can see here, Kiro did the review, found 79 lines, and returned a bunch of bytes. We can look at our terminal to see the response. So we can see here, executed with success, the message. Okay, this is not so good to see. So we can look at the result and in the code commit pull request. So you can access our repo, our pull request, and find the Kiro review. So here, the process is completed successfully. As I said, I'm using for review, but I can simply change the prompt in my application and do a build and a test and etc. And that's it, Julian.
Fantastic. So literally a headless code review running in 100% isolated microVM that is completely secure. You could run this, 1,000 times for 1,000 different customers, and their code would never see each other, which is absolutely awesome. I made a mistake earlier. I said that the microVM is built from a Docker image. It's not actually built from a Docker image that's stored at ECR. It's actually you store the Docker file in S3, and then the Lambda service is going to build the image based on that Docker file. That's correct, Ayush.
That's correct.
Okay,
now,
yeah.
if folks have a repo or a container image that they want to start with, the first line in the Docker file can be from and pointing to that image in ECR. So, but yes, generally the artifact is similar Lambda functions. It's an S3. We pull the artifact
coming from S3. So yeah, sorry, I said ECR and I was thinking S3, and then I was like, hang on, I made a mistake.
I have a question about. I have a question about the format in the chat. The format is not good. I believe I agree, because I didn't treat that. But we can format using skills in Kiro. We can use prompt and everything else. We can apply in a harness agent. You can do to make the format better.
Cool, excellent. Excellent. Thank you very much, Ricardo. I've lost. I've got to take off Ricardo. Yeah, a bit slow today. There we go. That was back to my demo. It just bombed out, and I just restarted it, and it came back up. So you can see that was probably silly, but there you go. So I'm now proxying locally, connected off to my serverless patterns repo, which is over here. So I could, do anything over here. I could go and edit any files, and if I was to then suspend this microVM, or it was to auto suspend, I could come back, 7.5 hours later, and everything would be persisted as well. Which begs the question, because our amazing Jeff Barr said, Could this be used to create temporary, super cost-effective development environments for students? Yes, it absolutely could. Just as if we're running Visual Studio Code here as well. However, if you want a terminal environment, you're going to need to think of some other kind of software that's going to run that, because Visual Studio Code doesn't have a terminal. But yes, this is a micro VM. If you could proxy some other process, or I know some people could probably have Visual Studio Code running locally, which could then could maybe proxy via WebSockets to a remote session. Any other ideas, clever people?
Yeah, can I jump in on that real quick?
Please.
So that's actually, I have a working example where you can actually, Visual Studio Code does have a terminal you can use and get to the underlying terminal, at least the one I built. And so yes, you can have, so if you do, I think it's Shift Control tilde, we'll bring it up on this. But if you have the underlying terminal set up. But yeah, Jeff, we actually did this. Before we released this, we actually brought in some students and we're showing them this, and we wanted to do a workshop. And I think I showed the team this, and we got really excited about it, because I built this, basically, it's this vending virtual or micro VM thing that has it has it all in there. I'm actually bringing it up right now. It's not as exciting because it's all blank at the moment. But they had a username and a login, and then it launched their own micro VM. If you refresh it, and you had this working environment. Where this gets really interesting, though, is if you tie, and I think, Jeff, I answered your question on this. If you tie S3 files into this, right? So what happens is I've got an example. I'm going to I'm not going to show this one in a second, but I've got several of these, and I know several of our other teams of members are working on this. But one of the examples I'm going to put out in a little while is this. It's Claude or Kiro in a CLI, so it's like a focus agent, but it uses S3 under the hood. So when the micro VM comes up, it mounts the S3 and it mounts that at your workspace. So then when you work in your workspace, anything you do in there is persisted. Not just the 8 hours that the virtual the micro VM is up and running, but a year later when you bring the same micro VM back up and it mounts that same one or a different one. You can have, what's really cool is I could be on my iPad and on my desktop, both browser interfacing with the WebSocket, and it's like a peer programming idea. So it's really pretty slick what you can do these. So the short answer, Jeff, is absolutely yes. It works like a charm.
Excellent. Thanks, Eric. So, Ricardo, just back to your use case. You had one for Kiro headless mode, but I know there's one available for Kiro, for Claude headless mode as well. And basically, I will share the link here. Serverless Lambda.com patterns, services. We've got a new sort of service Lambda micro VMs, and all the examples that we're talking about today are there. They are, really quick and easy to deploy. So if you want to go and try these out and see the art of the possible, that is there as well. But yeah, Ricardo, other kind of things that you've been playing and cool use cases before we get to Eric's demo.
Yes, I don't have a demo here, but this Kiro is one of the best I did. The VS Code is a good one. Another one is to run untrusted code in a sandbox environment, so you can spin up this in a micro VM as well. Actually, we have a sample this on the serverless land, and we are working a bunch of others. We have a lot of possibilities.
Cool.
Yeah.
Excellent. Eric, what have you been building?
So I got serious about this. We've got some building environments and things like that, and that's really cool. But come on, let's get to the real purpose of why we should be using micro VMs. So if you're very serious about this, then what you're probably going to do is you're probably going to build a multiplayer game, right?
Obviously.
So what I built was this multiplayer game server that could come up and down. So this is like my dashboard. Now, you may think, Eric, this is beautiful. Why aren't you a designer? Well, I could do that, but this design's fairly simple, but it's not great. But I can go in here and I can say, let's go ahead and create a game. This one's going to be a co-op game. I'm going to call myself EDJ Geek. And then I'm going to create this. Now, what's really cool is once the room comes up, I'm going to grab this link. It'll start this. So we've got that. So I'm going to grab a link and I'm going to post it both to here. Oh, nope, that's the wrong one. Let me grab it. Here it is in Twitch. So if you're watching, grab this link. I posted it both places. Yeah. Thanks, Julian. So, put that up so you can see it and type that out. Now, I haven't tried this, but more than maybe 2 people, so we'll see how it works. And if there's a problem, it's not going to be the MicroVM. It's going to be Eric's front-end code. But let me let a few more people drop it. Oh, here comes some people. Okay, so we got a lot of people going in, and you can join after, but I'm going to go ahead and start the game, and off we go.
Room's already full.
So, what's that?
Room's already full. I'm too slow.
Was it full? Okay. Yeah. I may have a limit on that. So we can play this. Now, what's really cool is I'm going to go here, and I'm going to pause the game. Now, theoretically, did everybody's game pause? Okay. What's actually happening under the hood, I'm pausing the WebSockets, obviously, the front end, but I'm also pausing the MicroVM, right? It actually calls the command and pauses the MicroVM, so we're in hold. Now, I'm going to resume this now. I'm still working through the code. It's a little buggy, but let's go. Oh, it resumed. Yeah, there we go. So you should all be able to play. And there we go. Okay, so now I created a poke. Oh, I just died. I've created a poker room that you can do that. You can do Tetris, challenge Tetris. So let's do one more here. I'm going to do this. We're going to do a free-for-all death match. Okay, are you ready? So I'm going to create this game. Now, this is a brand new VM that is spun up. And for those of you who are asking, how fast did it come up? Well, there you go. You just saw it. So let me go ahead and, all right, I'm going to post them. So, yeah, I guess I have a limit on the rooms. So I'm going to post it. So jump in quick. And I will be sharing this code if you want to try it later. Let's go ahead and see here. If anybody else joins in. There we go. Alex, okay. All right, I'm going to start the game, but you can join after the fact. Now, here's what's cool is I can now shoot you. So, someone got me. All right, so you get the idea here. But you can do this, and this is just WebSockets and front end, but the MicroVM is handling the communication and the connectivity. And so there we go.
Eric, you made my Kilo demo so boring after that.
Well, yeah, but one's useful, one's going to get me fired for doing too much, right? So he explained, look, I was testing this, right? So you're going to try it out, but I really encourage you to. This is an easy one to play with. Now, real quick, I'll show. I'm gonna pause the game, folks. Or you know what? Just go ahead. I'll leave it up and running there. But I am going to show this real quick. This is the architecture, and so you already saw Ricardo showed bringing them up and how do you start them and how do you tokenize and do that kind of thing. So what we're doing here is hopefully you can read this. It's a little fuzzy, but we've got your host. You have guests coming in, and we're using API gateway or we're doing WebSockets off the actual data plane. What I'm calling it the MicroVM. But I'm using a Lambda router function. This is like, it's running my front end. Well, my front end is in an S3 bucket, but it's actually when you sign up, then you have the ability to start your game. So that router will actually take and insert the token. It'll mint a token and then start a Firecracker for you. So basically, I'm proxying that so that you don't have to do it from a CLI or something like that. So you get the idea. I'll probably push this repo out later today if you'd like to play around with it. And with that, Julian, I pass it back to you.
Sorry, just one quick thing here. And to really drive home the point about the combination of speed and isolation. Now imagine if you wanted your users or your gamers to customize this, right? And provide scripts on the fly. You can, because the game is running inside an isolated compute environment and you're not worried about breakout. So any malicious scripts that anyone applies would only take down that game room, not impact your other users. So that's where MicroVMs really shine, right? You get the combination of strong VM level isolation and rapid startup speed, which means you can deliver really responsive experiences to your end users.
And I suppose every single game you just spin up a new MicroVM. It's not, I need to reuse and clear things out and worry about that.
That's right.
Because it's so quick to spin up. Every single game, every small kind of thing that you need. Yeah.
That's right. We used that to our advantage when we did when I was talking about doing with the students. We were showing them micro VMs, and what we were able to do is say, look, Claude is in there and it has no limitations. Kiro is in there; it has no limitation. It has permissions to everything. And where I'm securing that is saying, okay, but it only has the micro VM itself has this role attached, which says you can do this, this, and this, but not this and this, right? But other than that, you could go crazy because I didn't have to worry about it deleting all my email and that kind of stuff. So
awesome.
Yeah.
Well, Detox already got the next feature request in. I want to play Super Mario on this.
Yeah, I'll get right on that.
Exactly. Next prompt, and then why Horn Dark Souls? I think I read MicroVMs has an 8-hour execution time limit. What happens after that? Like if I wanted to extend the session further?
Currently that's the maximum supported duration. We've had a few requests for longer duration since we launched. In the week since we launched. So we'll circle back on that. But please do keep in mind that these are meant to be ephemeral by nature, right? So there's a reason why there's a time bound.
Let Ayush or any of us know your use cases for this as well, because also this kind of thing can be used for absolutely everything. And so, I mean, I'll be honest in saying, we're a bit unsure of what everyone's going to do with it. And so also want to start a little bit smaller. Technically we can increase it, but there are other, weird things to think of, which we don't know yet. So tell us your use cases, tell us, how, why, what, when, all the kind of things you want to use it for. And I promise you the debates internally have been extensive about all the possibilities for this as well. We came out a week ago. We'd really love to hear from you of what is going on. And Sipster just said, I like the idea of being able to pause an online multi. I just want to reiterate what Eric said, that it wasn't just pausing the WebSocket connection. Literally the whole micro VM is paused, in effect shut down. You don't pay for anything, and then resume
pause the billing.
Pause the billing as well, and then resume that super quickly when a request comes in. So that is, you're not paying when it is done. It's not just a it's not like a hibernation on a laptop or something, which is just going to close all of the disk or something. Literally, the memory is just being pushed to disk as well, and you can see how quickly that responds. Everything in memory, literally the positions of asteroids on the screen are just there as well. So yeah, super cool.
Yeah, and sorry, just to double click on the pause the billing part. Yeah, you're paying for storage at that point, not the active compute. So especially if you have minutes of idle time, like dropping it down to storage level costs it can be a big can be meaningful savings.
Yeah, definitely, especially if you're using that at scale as well. And then there was a question: what Unix user permission Kiro Claude may have on it? Anything you want?
Mm-hmm.
You can assign that as you're going in. There's as you format it, you can have them come in as root. You could create a user. So you have to think about this as like scripts. When I'm creating a micro VM, I can run different things. So for example, on the student micro VM that I was talking about, we did some things because Claude can take a while on first start. Choose your theme, choose your, Kiro does the same thing, or AWS CLI on the very first start, it grabs some stuff, it caches some stuff. So you can do a lot of that before you run your snapshot, right? So that gets really interesting in understanding how the snapshot works. What do I want in place before that happens, so that when it comes up, user set, preset, permissions in Claude are set, permissions in Kiro are set, those kinds of things. So a lot of power there.
Yeah, and I'm just going to bring up the example I was showing, because it actually shows those, running around, showing those lifecycle hooks. So you can see these are basically API endpoints as part of the Lambda MicroVM service, and you can wait until something is ready. So this is where you're going to set up your environment, download your bundles, do the installs, do all this kind of thing. And this is, in effect, your Lambda cold start process, but you've got full control over what happens in that cold start process. And then you can sort of say, when you want to run the micro VM, when you want to suspend it, when you want to resume it. So these are just the lifecycle hooks that you can do. And then when you want to terminate it as well. So you can hopefully see behind the scenes of what that is happening. And so if you think of the cold start process, you can spend as long as you like doing the cold start process, because ultimately this is an asynchronous process. When you then create the micro VM, install your binaries, set up everything, and then sort of like snap start, once it's all ready, you say, I'm ready to create a snapshot. It is then going to squash all of that to disk and store it cleverly, that it's also optimized to be able to respond from cold starts. If you've seen how our container image works with Lambda, it's using the similar kind of caching technology. So you push that all down to bits, and then next time when you then start that micro VM, I nearly said invoke, and I would have had to hit myself. You're not quite invoking a micro VM, but starting a micro VM is doing the same thing. It's just rehydrating that from snapshot, and everything is running. Everything that you started in your init process and running is there. So it means your init process can be minutes if you like, installing a whole bunch of stuff. But when you actually start that micro VM, literally as quick as we can optimistically copy those blocks back into the micro environment and start it, which could be a second, maybe two, maybe a few seconds. So yeah, really easy. I'm glad to see we have what's actually going on. EDJ Geek is dominating.
I was
Darryl
listening
Russell's.
to you.
No, it's fine. It's fine. I understand. I'm sure that, and then Darryl was nice, saying, really launch, guys. Thanks, guys. And Eric just trampled on him, saying, I beat you in asteroids.
Darryl is a much better person than I am. We all know that.
Yeah. Well, he's come back saying, recognize that you've killed him a few times as well.
I did.
So, ID Carlos, the pause is pausing also the 8 hours limit. No, that isn't actually. So it's pausing the compute billing. But yeah, it's not pausing the 8 hours. The maximum time currently for a micro VM is 8 hours, whether you pause it or don't pause it as well. And then, Sipster, I love watching Counter-Strike tournaments. So imagine there is a hacker in a major with possible 6-7 figures involved. They can just completely stop everything and resolve the situation. Yeah, I mean, it could be up to 8 hours, or somebody could hack a game. That would be a possibility. But yeah, you've got full control. When I showed you you could easily terminate if something goes completely wrong. Just terminate and saying, sorry, hacker detected, need to respawn your game, and off you go. Joe Alioto, our observability friend, Lambda MicroVMs friendly fire tournament to win EJ Geek. There we go. That's the next few days. And I think you're right, Eric, that yes, and absolutely, this is going to be the hot topic of MicroVMs. Yes. is gaming online. I love it. Okay, Ayush, anything we haven't covered or are missing, or you're just like, can we please get off this games? I want to talk about the serious stuff, actually.
I actually wanted to go back to the part about the hackers stopping the micro VM in the middle of the game, right? Like, that's a good way to talk about the permissions modeling, because there's really two levels of access. First is IAM permissions on who can call run micro VM, suspend micro VM, terminate micro VM, and so on. And second is who can actually connect and interact with the micro VM, right? Mm-hmm. The second is controlled via the JWE auth tokens, and they don't necessarily give you permissions to call operations on the micro VM itself, right? So you can, if you're the admin, you can have full permissions and maybe talk to a special port where your main app with elevated OS privileges is running, and you want to run a game server where you want your end users or clients to connect. You can vend out a different auth token scoped only to the port where that game server is listening, and have your clients actually just connect to that port. So yeah, we've got you covered there too. Your tournament will continue uninterrupted.
Yeah, no, excellent. I love that double auth model where you've got the sort of operator role and then the user role. And there's cool stuff you could do in that user role as well. If you did have multiple users connecting in, you sort of can know their identity. You could, you're running code in a server. You can do whatever you want on that identity and try to work that stuff out as well. Oregon TK Atom, can the pause state stored memory be passed onto another micro VM to overcome the 8-hour limit? Not directly, but if you then made it
a bridge
via S3 or somewhere else, yes, you can. So think of it as a Lambda function runs for 15 minutes. If you need to maintain state outside that, you write to a database, S3 files, EFS, something.
Yeah, that's I would throw that in because we're having discussions internally about this. We've had several, but to me, two really good options are S3 straight up, Bodo to S3, write to it, read from it. If you're doing small amounts of, hey, here's the state, and then when I start back up, bring the state back in, right? So, and you can do that with the hooks and stuff. But if you're doing bigger stuff, like, look, this is my work environment. I've got students that are going to work for 2 weeks on this. We need to save lots of stuff and keep that persistent. Then I would do the S3 files. And again, you can have that during the snapshots and the hooks and stuff like that. You can have that all configured where it comes up. All their stuff is still there. You lose context from the model you're running, but you do that when you close the terminal and open it anyway. I mean, you can write out some memory as well. So it's kind of the same situation. But yeah, so really think about how, what are you looking at? What's your workload? What does your data pattern look like? Is it worth writing to S3? Is that quick? Or should we run a POSIX file system and write as we go?
Cool. Thanks, Eric. And one other thing, can I resize? Thanks, Mighty Core 1. That's a cool name. Mighty Cores within our microVM. Can I resize the microVM? Also, maybe during runtime, CPU, RAM, disk. Do you want to cover that? And then also, we didn't quite talk about burst, so let's cover that as well.
Yeah, actually, that's the both points are very related. So the way you with most compute environments, right? What you specify is the peak, right? And you're kind of provisioning for the peak. With microVMs, you give us a baseline configuration, and the peak is 4x of that baseline. That ratio is fixed today. So you can't dynamically change that baseline when the microVM is running. But effectively, what this model lets you do is you can run at the baseline for most of the time, and choose a baseline that corresponds to your average CPU memory utilization. And then during temporary spikes, you can go up to 4x of that baseline. And during the period that you exceed the baseline, you're only paying for what you use beyond the baseline, right? So does that answer the question, Mighty Core? And sorry, the last point there, disk is for each VM size that you pick, there's a maximum amount of disk that you can get.
So that's proportional. So that's the idea, is to keep this simple as well, that, as with Lambda functions, you've got a sort of proportional config that you can use as well.
Yeah.
Just quickly, our time is running out, but I just wanted to show this link as well, which is using Lambda MicroVMs as a sandbox for Claude Managed Agents. So on launch day, we basically had an integration worked nicely with the Anthropic team to be able to, have a sandbox for a Claude Managed Agent that could then, run your Claude Managed Agent, but you can use microVMs on the back end to be able to handle that as well. So that's a pretty cool integration, and there will be many more, I think. Yeah, I think what I've heard, and community people have been rather excited.
So you start closing your laptop again when you leave. See people walking around with their laptop open. So yeah, that's exciting.
Yeah. Excellent. Well, Jeff Barr has appreciated the show. Jeff, we always appreciate having you here as well. I learned a lot. Well, thanks to everybody on the stream as well. We're actually taking a bit of hiatus for live streaming at AWS over the next month. Plans are afoot for coming after that as well. Not entirely sure. We'll have to see you sometime, not same time next week, but sometime in the weeks ahead. But really, if you are in LATAM, you're in Sao Paulo, you want to jump on a quick flight and hear the awesome Eric Johnson and Ricardo and some of our real, absolute experts talking serverless literally from the beginning to the most advanced customer use cases that you can think of. If you're a student and you're just trying to figure out what this AWS thing is, what the serverless thing, you're a student and you're freaking out about your job, like what does AI mean for your jobs? Come and join us on the Fridays and Saturdays where you can learn some stuff. We can tell you about the cool future that is hopefully ahead for all of us. So thanks everybody for joining. Thanks Ayush, thanks Eric, thanks Ricardo. We really appreciate you spreading your great knowledge. And
Thank
to
you
all of
all.
you for watching, thanks so much as well, and see you sometime. Goodbye.